Oh yeah, this. All right, guys. So, quick announcement before we get started today. I'll have a lot more information out on Discord by tonight or tomorrow. But basically, ACM is hosting a event on October 12th at 6 p.m. There's a security consultant from Accenture. He's going to come in and do a pen testing presentation and also talk about Accenture and their job opportunities there. Like I said, it's being hosted through ACM, so it's not our event. However, you can still attend because they're our parent organization. So if you guys are interested, just answer just react with an emote on the announcement I'm going to post tomorrow, and we can get a head count, see who's going, and hope to see you guys there. Learn about pen testing.
All right, so just a little quick announcements. Thanks Nick for ECM, but on October 6th, on Wednesday, we have a resume review with Raymond James, and that will take place over Zoom. So please sign in and send in your resume at resume.ufsit.club. And we'll be starting blue team meetings. If you want to learn about network defense, Jack Polk over here will be starting blue team meetings next Monday in CSC 309. What? What's up?
What's this?
Yeah, it's upcoming Monday. Yeah. In CSC 309 at 6:30. So please come learn about network defense. And for mentorship, the apps are still open and they close tomorrow.
Yes, and if you're interested in being a mentor, this still counts. So if you want to sign up to be a mentor, this is good too. And if you still want to be a mentee, got a little bit of time left. So please sign up as soon as possible.
Yeah, the URL is there if you want to send in the Google form.
Before you start, I just want a quick thing about the resume. When you put in your resume, you'll see a choice to do both the resume review and also the security career fair. You don't have to do both of them, but since the resume review is closer, I just put both of them so you can sign up for just have a resume collected for both events. But if you change your resume later, maybe due to the resume review, you can sort of resubmit the form and then just select security career fair to get your resume collected for that. And I'll take the most recent submission. So yeah, that's all I want to say. Thank you.
All right, guys, I'm very excited for this topic. Mostly because, Pwn is my thing. I've been doing it for a bit. But yeah, welcome to Intro Binary Exploitation. So just a helpful background for this. It's helpful if you know a little bit of assembly, x86 or x64, and some kind of memory internals, like how, for example, like how a stack works on a particular architecture, or just a stack in general. And it's also good to know some Python and a little bit of C to help you get you running quicker. Also debuggers. Yeah, knowing how to use a debugger will help you a lot because you will be frustrated when doing this. I will say that of the 4 up there, GDB, it's my pick. WinDebug is kind of trash. Right, John? Yeah, exactly, not of approval. So just broadly, what is Pwn? Well, if you kind of think of it, it's like a game. There are rules to it, and you kind of win it by breaking it. So, but little more like non-metaphorical wise, it's kind of, you're basically exploiting other people's mistakes, right? When they're writing software, they'll mess up somehow, because that's just how it is. We all have to do the debugging thing. But yeah, you take advantage of their mistakes, you exploit them, to get the program to do whatever you want. It's very fun. So why Pwn? Well, you can do it for fun and some profit. You make actual money by doing bug bounties. Companies will actually pay you if you can find vulnerabilities in their software. And sometimes it's not just websites. There's also CTFs. Like, for example, on our CTF team, Colonel Sanders, we have occasionally there'll be some categories where you'll actually be pwning binaries that have particularly vulnerable bugs, that have bugs in there that you can actually turn into exploits. And you can also use it on your own time if you want to determine like how secure the software that you use. Also, just game hacking. Game hacking is good too. So just a quick thing before I start. What is the bug here? In this like 10-line C snippet, there is a bug. You see it? maybe a little hard because of the purple, but yeah, Sean? Yeah, exactly. You can read in 40 bytes into a buffer that's only 20. That's kind of a problem. That's kind of a problem. It's basically you're dumping the equivalent of like a pool into like something like a water bottle. It's just not going to work. But we can leverage that. But we can use that bug to get us code execution, arbitrary code execution. How? Buffer overflows. So Sean was right. The bug is an overflow of 20 bytes into that buffer, and with that, we can overwrite data on the stack. Any kind of variable on the stack that we can hit, we can overwrite, change it to whatever we want. It's perfectly legal. And if we are lucky enough and these, program aligned for us correctly, and our overflow is big enough, we can hit the saved return pointer on the stack. So when the function exits, or at least when it hits return and it goes out of that function, it'll go to wherever we want. So that's very fun. Now, in this one, there is a bug, and we actually fixed the stack buffer overflow bug, but there's another one in here. You guess it? What? Exactly, it's a format string. Why is buffer the first parameter to that format string, or is printf? And that's an actual problem because according to the man pages, printf, the first parameter of printf is the format string, right? And the format string is where all the substitutions happen based on the parameters that you're thrown in and also on the format specifiers. So if you're able to control that format string and what it is, you can get arbitrary read. You can read as much as you want from the stack. You can leak all sorts of values, any kind of secrets that's stored on the stack. You can see them, you can leak them. That's great. And also for some reason, percentage n exists. I don't know why, because this is just the worst idea ever. It's kind of useless, and I've only seen it used for exploitation, but it writes the number of bytes printed by printf to an integer in the a variable on the the parameter list. So like if you're printing like 10 bytes through printf, it would write the value 10 to a variable that's in the parameter list. And you can use that for arbitrary write. Why? So if you're able to control the format string, you have arbitrary read and write on the stack. Like that's amazing. And another type of an exploit strategy that you can do if you have stack buffer overflow is called RAP, or return-oriented programming. So you can use little snippets in the binary. Like for example, from that screenshot, you can see like you have like pop RDI, pop RBP, and all that. And you can kind of use it to program, like I use it in like loose quotes. You can use it to program the binary to have it do any kind of code execution you want to, And if you have like the proper like environment set up, you can even return to other libraries that the process loaded, like for example, the C library. And you can do anything with the C library. Now, there's a lot of different vulnerabilities and exploit techniques in Pwn. You have heap, use ever free, double free, because actually it turns out that if you're double freeing a variable that's been allocated on the heap, that's a problem because you can exploit that. Race conditions, all sorts of stuff. And there's also some more, I'd say, advanced exploit strategies like SIGROP, which take advantage of how Linux does signals. Other heap stuff, right to CSU, stack pivoting. It's a lot. It's a lot of ways that you can take advantage of the problems that exist in like a program and turn it against itself to your own purpose. But like many things in life, you have all this fun, by just hacking all these programs to get it to do whatever you want. Of course, like many things in life, they'll get taken away from you. And that's where the mitigations come into play. So the first one, that's probably like I think it's like one of the very first mitigations, It's NX or like write or execute, which means that on the stack, no execution is possible. So you can't do what's called like shell code where like you put your own assembly, like your own like actual assembly program on the stack and then execute that. You can't do that. And how you defeat it is just, well, use something else. You just go use route. Now, and there's also stack canaries, which just place like a little cookie in front of the return pointer, which is supposed to be like a security check, where if you're trying to do a buffer overflow, you're going to hit that pointer or like that little stack cookie. If you hit it and change it before the function returns, it'll check that cookie again. And if that cookie has been checked, the program just outright kills itself because it's like, oh my God, there's stack buffer overflow has been detected. This is a security problem and actually like kills itself. And you defeat that by using the format string bug from earlier to just leak that value from the stack. You know, just leak it and you just place it how it is, kind of like Indiana Jones style. It's all good. You're perfectly good on that. There's other mitigations, like for example, ASLR, which is more of a system-wide mitigation. So when your binaries are loaded, and like they have all these like libraries or linkers that's also bringing in, the addresses for those, they're going to be changed. So you can't exactly like, you know, return to something like libc because the address for libc changes every time. And pi or position independent executable just changes. It just does the same thing, but it just, but it does ASLR, but for the binary. So you can't do wrap at all, and you just defeat that by using a format string to leak known symbols from the binary, and you just, you know, do some math to figure out what it is in memory, and bam, you're able to go. Now, for further practice and some other resources, I highly recommend Phoenix. Actually, I'll be doing that after this. If you want to learn more about Pwn, I have Guy in a Tuxedo's Nightmare course. Highly recommend, it's really good. If you're doing CTF problems like we do on Colonel Sanders, highly recommend Pwn tools. It has pretty much been the de facto standard for CTFs. Also, and if you're going to reverse engineer or at least do some initial like reconnaissance into the program, just to like reverse engineer it, figure out how it works and what bugs you can find, Binary Ninja is good if you can pay for it. Though there is student discount. John here loves that. But if you don't want to pay for Binary Ninja, Ghidra is also free. You know, you already pay for it with your taxes. Any questions before we move on to some actual exploitation? Yeah, Cole?
What do you think of Jeff?
Jeff?
Yeah.
Jeff is also very good. I did forget to put that up there. But yeah, Jeff is a very nice wrapper for GDB. It very much helps you in the when you're doing exploitation, even for like non-CTF stuff. I actually found it helpful. All right, that's it. All right, so I will be booting up a VM. Thanks to QEMU. Yeah, let me just get it properly zoomed. All right. Yeah, this is a VM that's been provided us by Phoenix, as I listed earlier. And actually, no, it's not like that. It's user. So we're just going to go through like challenge or two just to get an idea of binary exploitation. Yeah, let me try. Come on. No, hold on. I think it's just being slow. It's probably Zoom. It's likely Zoom. It's always Zoom. No, I have a better idea. I'm just not going to do this. All right. I'll get the Zoom thing out of here. What was it? Red to win. Yeah, let's do red to win. All right, so this is a challenge from ROP Emporium, which is also it's a website that has a bunch of binary exploitation challenges that exclusively are ROP oriented. At least that's a technique that they'll tell you to use. But when we execute the binary, it just tells us, hey, feed us. They just give it data, and then it just exits like that. And if we just do quickly look at this with GDB, let's win. Let's do run. We just execute it. I'm going to kick out of it. And this is what Jeff looks like. It is a lot. So it'll take some time if you're looking at it to, get used to all that data. Now, if we just look at this as red. Now, from prior RE, you would see that there is a function called ret to win, and it just calls system. And we are going to get that address right there. And I'm just going to make I'm just going to make a simple exploit script in Python. And this is Pwn tools. Pwn import star. Yep, that's the right one. So was it IO equals process? Let me just verify what the program name is called. Okay, cool. Then we're just gonna do simple payload, straight in this Python variable. And just to double check, we need to know how big we need to make our buffer to like overflow to hit the return pointer on the stack. So we can kind of find out by doing some Python magic. So if we do this as, okay, so the main function calls pwn me. So we're gonna look at that. And I see down here, there's going to be like a little reads call. So it's just reading input from, looks to be standard in. If you look at the calling conventions, EDI is the first argument. The first argument to read is like, where are you reading it from? And 0 is standard in. So be at pwn me plus 97, which is right after the read instruction. Sorry, we're gonna hit continue. We're gonna slap some A's in there. Let me get that right. And we're gonna do that. And after that, search count. Wait, what? Oh, I did too many. I did one too many T's. All right, so Jeff provides us like a nice command called search pattern, where actually will search memory for string that you give it. So we just told it a bunch of A's and it'll go find a bunch of A's. And it told us that it starts at, this address, the 7FFFFE like 260, right? And if you just do IF, which is actually provided by GDB itself, it'll actually tell you a bit about the stack frame. So it tells us like stack level is that, instruction pointer is that. I generally don't care about all this. I only care about like these two down here. Which is the save registers, which at RIP or like saved RIP down here, that is the address where the actual like saved instruction pointer is stored at. And inside of that instruction pointer, like where it leads to, is like the function that we will be returning to when we're like done executing pwn me here. So we're just gonna open up Python here. We're gonna do a little quick maths. So we took our IP, and then we're going to subtract it with stack one. Okay, we know our offset is 40, so we're just going to put a bunch of A's and just, make 40 A's. Payload plus equals 64. Now, where was this as phone me? Oh no, not that one. Yeah, ret to win was this one right here. So we're going to get the very first instruction for ret to win. And we are going to put that right here. P64 is just a function provided by Pwn tools that essentially just like pads, it pads the number. So like it's a 64-bit number that we're giving it. So that address that we'll give it, what will append to that payload byte string will be like a valid 64-bit like address. So the processor won't complain that, oh, this is invalid. Like, what is this? So we do that. We're going to do io.send line. Then this one will actually just send the payload, and then io.interactive, which gives us a shell. So we're going to write. Just going to have it right. Python 3 exploit. Yeah, nice. So yeah, wait, hold on. Oh, I think I know what it is. My heart tells me that this is what it is. Yeah, there you go. Yeah, so you see we got the flag. Hold on, let me just move the zoom thing. We got the flag right here. Nice. That's to that. Now, the fix we did here is that we had to add 4 as like what we did at the top. That's just stack alignment. Occasionally that will be a problem if you're doing buffer overflows and overwriting the return pointer. Especially because I think what was the issue is that down here we have push RBP and then like another move, but I think it was this push here that was like kind of screwing up the stack so much that when we tried to call system further down, it kind of like seized up and locked up somehow. I think it might have been like that move apps, which required that stack alignment. So anyway, yeah, so that's kind of a taste of buffer overflows. Does anyone want to see another one or? Yeah, Nick. You want to see another one? Yeah. All right, cool. All right, let me just move this one down here. All right, let me just kick. Quick exit. All right, what was the other one? Oh yeah, split. Yeah, split was a good one. Now, do you guys actually want to see me write the exploit live or just like talk about one that I've already written? Do it live? Do it live? You all want it live? Okay, fine. Shut up, John. You don't have an opinion. All right, so just ignore all those like zip files. Yeah, they're just like for the same challenges, but they're like in different architectures. I don't want to look at that shit. So, if we just run splits, it'll just say hi, just input data. We just slap those A's, nothing, cool. What? No, just MIPS, ARM5, and 32-bit x86. I mean, there is source. So, I would probably do it, but I don't want to make a whole tool chain for RISC-V, especially one that uses glibc. So that's just painful to write. All right, so rm exploit.py. I'm just gonna do Pwn template. Was it splits? And then we're just gonna call it exploit.py. All right, so Pwn template. Wait. Oh, Owen asked, can I also use simple write gadgets to align the stack? Oh yeah, for sure. You can totally do that. Yeah, you can totally do that. Thanks, Owen. All right, so this right here, this was auto-generated by Pwn Tools. It just gives us like a nice template so that we can only focus on writing our actual exploit instead of just doing a bunch of, like environment setup. So we just do payload equals B and 40. All right, I'm just going to set this up right here. If I recall correctly, actually, I'm going to open this up in Ninja because I think this actually requires a bit of RE to like know like what we can hit. Because if I recall correctly, there isn't a read to win function. Yeah, all we have is read. Yeah, nothing interesting. Although we do have system, but all right, benches open. I'm just gonna actually hold on. John, what is it? Binary Ninja / cloud? Cloud.binary Ninja? Oh well. So I remember I was doing this on a few nights ago. Yeah. And unpause it. Yeah, why did Jordan make a terrible site? All right, so we're using the cloud version of Binary Ninja, which I know John loves his cloud. This is burring, so we're gonna look in pwnme on the right side. And you just see that there's puts, printf, read. And I think if you like keep going up here, that is just reading like 60 bytes into 20, so that's good. But we have useful function right here. So it just does bin ls. All right. Wait, hold on. But yeah, we just see like right here, there's nothing like read to win that we could just like return to and hit that. So we kind of have to make our own win. So that'll be fun. Okay. So I'm just gonna use Ropper, which is a ROP gadget finder that's written in Rust. It's written in Rust, right? Very nice. ROP gadget finder. We'll basically go through the binary and like try to find like ROP gadgets that we could use. Like here, let me show you. Like here, we have pop RDI, pop RSP, all these that we can reuse. And since, as we kind of see here, pi isn't enabled, we can just throw in these addresses, overriding the instruction pointer, and we'll actually go execute those x86 instructions. Be very fun. All right, so just so that we can collect some, we're gonna go find some interesting gadgets right here. So pop RDI is a very good one. Pop RDI equals, yeah, we're just gonna set that here. And I believe in, hold on. Also, if we go here to strings, oh no, right here, strings. We also find bin cat flag. It's like, it's just sitting there waiting for us. So I'm just gonna copy that. 60160, okay. Yeah. I'm gonna call that cat flag. Okay, that didn't work out well. What the hell? 601060. Okay, we're just gonna write that. What was the other one? Just system? Yeah. Yeah, and we're just gonna look over here. yeah, for system right here. And we can just look quite literally just copy address, just be lazy about it if we really want to. What? Are you kidding me? Wait, 407 4B, okay. 407 4B, so we're gonna put pop RDI right here, and on x86, if you remember like John's talk from like last week, pop RDI, or like, yeah, RDI is like the very first, like in the calling conventions, that's like the very first parameter when you're trying to call a function. So we're going to try to put we're going to try to put like a character charge, like a string into RDI, and then we're going to call system. So it's essentially calling system with our like the command that we specify. But we have to find, in this case, we have to find that that string like in memory, but thankfully it's already there as we found on Binge Cloud. So we're just going to do payload plus equals page 64. We're going to call it, why did I call it cat flat? Then we're going to do an additional P64 system. And we're just going to put another io.send line. We're going to call it payload. But yeah, there you go. We're going to do Python 3, then exploit.py. There you go. You did it again. We called system cat flag. There you go. Yeah, we solved the split. That's very good. Oh shit. Yeah, hold on. Yeah, it says Zoom pop-up. But yeah, we called cat. Yeah, we got the flag down here by using RAP. Very fun. Yeah, John. What? What do you mean?
Where would you recommend somebody to start who doesn't know a lot about exploitation?
If you don't know a lot about exploitation, Guy in the Tuxedo's Nightmare is pretty good. I highly recommend it. The write-ups are of a quality, but it is a very nice selection of challenges that he's curated for himself to share with others, and it's actually been very much passed around other like CTF communities. Yeah.
Is there like a natural progression you see for getting do you start with one topic and do overflows, ROP, heap, order you would suggest?
Yeah, I'd suggest stack buffer overflow is like probably like the very first one that's like kind of set in stone. Like you need to get that down. Then format strings are good, especially to handle like the mitigations. And ROP is also a good one too. Like you can call it the third one afterwards. Because again, it helps to defeat the mitigations and also, just returning to, doing other attacks like ret to libc. After that, natural progression, like you could call it that, is you do heap. And after heap though, it can kind of turn to like whatever territory you want to go into, right? It's very flexible from that point on. Yeah, Cole.
Do you have any guides for learning
Reading the documentation. For Jeff, just looking in the docs and just checking looking up every command is like very good. There's not that many commands that Jeff like kind of sends out. You can reasonably read it, and plus they're very well documented. As for GDB itself, again, there's documentation online, but yeah, write-ups will paste that in, and also just use it. You'll learn a lot by using it. Anything else? No? All right, well, thank you guys for coming. It's been fun. I hope you all learned a bit about binary exploitation or phone, and just, yeah, it's a very fun field to get into. You can make a bit of cash, but yeah, it's all good. Thanks, guys.